The attachment point command is used to create smart assembly behavior for items dragged from the catalog. So they can position themselves automatically, size themselves automatically, and even constrain themselves automatically as well. If I click on this part, the attachment point command will now be available. I can select on that, and then select on a position on my part. That will create an attachment point at that position. Now I can right click and select Set Name and Behaviors on the attachment point. Then I can customize all the options available. In this case though, I'll exit out of this and show you a few examples before I go into the details. Here I have a few different examples of how attachment points can be used. Let's start with this simple playground example. I'll drag and drop out this platform. Zoom out, you can see there are attachment points all around this platform. Now if I right click in empty space in the 3D scene, I can click on Show, and then turn off attachment point display if I'd like to. So they'll still work in the background but just not be seen. So the model looks a little bit cleaner. Now you can see over here on the right hand side we have various items for this catalog. Now if I drag and drop a platform into empty space, it will just place itself in empty space like that. But if I drag and drop this onto my model here, it will find the associated attachment point and connect it with that attachment point. So you can see it's now attached itself to that position. Now I'll do the same again here, and I'll do the same in this direction. As you can see, it's finding the closest relevant attachment point with the same name and connecting to it. Now if I drag and drop out a slide here, you can see it will automatically position itself as well. Or if I drag and drop out a fence, or a ladder for example here, and a climbing wall over here. As you can see, each item is automatically positioning itself. Now I'll delete this and show you another example. Here we have a robot example which is also adding constraints. So we'll drag and drop out the base here. I'll zoom in a little bit. I'm going to fix that in parent, which is going to be useful for us using mechanism mode in a moment. Now when I drag and drop out the shoulder here, you can see it's going to automatically position itself. But what it's also doing is automatically adding a constraint as well, which you'll see in a moment. Now I'll add the arm, the elbow, the arm too. As you can see when I'm dropping this, I don't really need to aim very precisely, just approximately on the item I want it to connect to, and it'll find its position. Then I'll drop the wrist, and lastly the end point here. Now these have obviously all been positioned correctly, but they've also been constrained correctly as well. So if I turn on mechanism mode here, I can then drag the front of this robot and we'll get the correct mechanism movement behavior of the robot. Now let's have a look at another example. Here we have a simple fence. We can drag and drop out the fence, size it to our needs, and then drag and drop out a corner here, drag and drop out a new fence, then drag and drop out an end, and another end over here. These items are getting positioned, but they're actually also getting constrained as well, so that if I now resize the fence, they'll stay connected. Here we have another example with a more complex fence. I'll change the shading mode over to be a little bit lighter there. Now with this fence, when we push and pull it, we'll get new fence items patterned along. And each of these items has attachment points on it as well, as you can see there. Now when I drag and drop out the add fence, it will add it to the closest fence post that I drag it to. Just like that. Now for the last example here, let's have a look at this cabinet, which has a different type of behavior. You can now see that cabinet drag and drop down. We can then push and pull to size it. As you can see, there are 3 attachment points here. The side attachment points help me add in a new cabinet, which will automatically position in line with the existing cabinet. But this front attachment point has other properties in it as well, and actually has some constraint setting properties as well as some size setting properties or parameter setting properties. So you can see if I right click and click on set name and behaviors, there are a few extra properties here, these variables. Basically, these variables are saying the door height should be equal to the cabinet height minus the kickboard height, and the door width should be equal to the cabinet width. Now you'll see when I drag and drop out this door, it will automatically size to match my cabinet. The same here. And now if I resize my cabinet, the door will follow as well. Now it's worth noting that in this case we may actually want more than one door, and we could very easily customize this to be a 2-door item when it gets over a certain length. So for example, we could say when this gets over 1 meter, add 2 doors instead of 1. We could very easily do that as well. In this example though, it's just one simple resizing door, as you can see. So there are a few examples of how attachment points work. Now let's look at how to create them. I'm going to start by making a simple table. I'm going to drag and drop out and extrude, and then resize this. So I'm going to make it, let's say, 1 meter. Oops, press the wrong keyboard key there. 1 meter, and I'll hit enter. And then I'll make it 600 wide, hit enter. And let's make it 50 mil high. So there we have our very simple table. And maybe just for fun, I'll add in some blends to the edges here. At 100 mil. I'll press Ctrl Alt to select behind here. And I'll select that back edge and hit OK. And now we're going to place some legs on this table. Maybe we want to have interchangeable legs. So because of this, I'm going to add these legs as attachment points. I'm going to click on the table and then click on the attachment point command and place an attachment point on the bottom of the table here. Now I'm going to click on that attachment point and then activate the tri-ball. And now I can move it around with the tri-ball. Note, to click on an attachment point, you first need to click on the item it's part of. For example, if I try to click it now, nothing will happen. I'll select onto the part. So if you click the part first, you can then select the attachment point. This is also worth noting if attachment points are hidden. So you can see if we have the attachment points turned off, then you won't see it until you click on the item it's part of and the level it's part of, like that. Now I'm going to click on an attachment point, activate the tri-ball. Now I'm going to right click and select edit distance from point. I'm going to choose for this to be offset by 100 millimeters from that point. And then here I'm going to right click and select edit distance from point and choose for this to be 100 millimeters from that point as well. Now we can see that there. Now you can drag and drop attachment points into the catalog if you'd like to reuse them again, for example. And you can also copy them around. So, whoops, let me just click down onto there. You can also copy them around with the tri-ball. So you can right click and drag here on the tribal and select, for example, link here, one at 400. There we have a linked attachment point over there as well. Note how you copy an attachment point may create different behavior than expecting for how it actually positions when the model is resized, which I'll show you in a moment. Because we place these on this bottom face here, the attachment points have no reference to the actual size of the shape. So if I was to change the size of the shape, the attachment points would actually remain where they are. So this is something important to know, which I'll show you how to customize in a moment. But basically speaking, to change that, you want to use a reference item that will move when the model is changed. So for example, the first place you click to place an attachment point could be the corner here, and therefore that would move that attachment point when you move the model. In fact, instead of copying this one, I'm going to create a new one here and do it with that method and show you the difference. I'm going to click to create an attachment point. I'm going to create it on this point. You can see this one's on a different orientation because I selected a different point. So I'm going to click onto this one, activate the tribal, I'm going to rotate it 90 degrees, and I'm going to move inward here, and I'm also going to rotate it to be the same as our other one. So I'm going to rotate it like this, 45, and then I'm going to right click, select edit distance from point, and set it the same distance as our other item there. 100 by 100. Now you can see if I resize this in this direction, that attachment point is now following, whereas this one down here isn't following. So that's something important to note when creating attachment points. To create that follow behavior, you need to first select when you place it on something that will actually move. So for example, you could select on this face if you just wanted it to move with this face. I'll do that now. And then if we resize it like this, it'll move with that face. And we do the same over here. But it's worth noting, because that's placed in a random position, whilst it'll resize with this face, if you actually resize in this direction, it won't, because it's just placed on that face. So therefore, if you click a point, it will now have two references for the geometry. So for example here, if I choose for this to be at the midpoint here, because I've chosen the midpoint as opposed to just the face, now that'll actually stay at the midpoint as I change this around. As you can see, it's now moving and following the midpoint of that item. Now let's delete those extra attachment points for now, and we'll go in and start customizing them. I'm going to select onto this one we have up here, and I'm actually going to rotate it to where it was before, at 45 degrees. Just like that. And as you can see on the attachment point, we can see each axis. So we have the red x-axis, the blue z-axis, and the green y-axis. So this helps the positioning of shapes that connect to that attachment point. So generally, to connect something to the attachment point, on top of it in this case, we want the z-axis to be pointing in the opposite direction. Now I'll show you that in a moment. First we'll set the name, so I'm going to right click and select set name and behaviors. I'm just going to call this one AP for attachment point, but you can call it anything you like. It's worth noting that attachment points will only attach to other attachment points with the same name as them. So you can create very complex behavior based on the name of the attachment point you have and you're using. You can have many different attachment points on the model, but for example, when you drop something, it may only attach to a few of them that have the same name. Note you can also set different properties for the attachment point, whether you'd like it to be neutral, female, or male. Basically, a female will only attach to a male and vice versa, and neutral will only attach to neutral. So for example, if you have something with a front and a back, you can use the female and male to represent the front and the back, so it never gets mixed up and you never have it going opposite directions. For example, a simple way to think about that is a battery. If you have a battery with neutral on both sides, it could then be drag and drop out and connect in the wrong way instead of in the correct way, staying in the direction you want it to go. Whereas with items where the direction doesn't matter too much, you can use neutral. I'm going to use neutral here. Note we can also set variables and an alias name. I won't go into those yet, I'll show those a little bit later. And we can also set constraints. In this case, I will set a coincident constraint, which will lock the position of the item. We can also set other constraints for the position of the attachment point relative to the other attachment point. So basically, coincident means it's just going to stay connected to that point, but it can still rotate and other things. Let's now hit OK. It's going to be AP_N. And now I'm going to right-click, drag and drop a cylinder out. This will be my leg. I'm going to select drop as part, and I'm going to extend this one. Let's make this, maybe it's going to be a coffee table, and we'll make this a 450mm leg. This is obviously a very simple design, and as you saw from the examples, you can do far more advanced designs than this with your attachment points. Now let's make the leg a little bit wider. Let's say it's going to be 60. And now what I'm going to do is actually move this away from my model to place the attachment point on it. I'm going to move it up here. And then I'm going to click on it and place an attachment point. Note, because the anchor is in the same location, it can sometimes be hard to select both of those items because they're in the exact same spot. So I'm actually just going to move the anchor a little bit out of the way so that I can easily place my attachment point here and then edit it later. Now I'll click on that. It's worth noting the anchor point also helps determine how something will position, because the anchor point is how the item comes out from the catalog. The anchor point is essentially where the mouse is. So if we had an attachment point on both sides, the model would generally position or connect with the anchor point that was closer to the side, the attachment point that was closer to the side with the anchor, because that's where the mouse is. So if we had this same one that could attach to there on both sides, it will generally always use this side when dragged from the catalog because the anchor is closer to that side. You can also customize it later and choose the side it goes to from the catalog, but we'll go into that a little bit later on. Okay, so now I'm going to go in here and I'm going to set this one. I'm going to set name and behavior. I'm going to do neutral and do AP for the name here. So now that will attach to that. And I'll also add that coincident constraint, like I mentioned, which I didn't add to this one either. And actually, I'll add it without the coincident constraint, and then I'll add it with it and show you the difference. So now, if we drag and drop this into the catalog, of course, if we just drop it into empty space now, it will do what we expect. It will just kind of place itself there. But if we drag and drop it onto our model, you can see it's going to automatically find where it should go. Now I'll delete the existing one here. Now the main difference for the coincident constraint I was referring to adding earlier is that this is now not locked to that position. So I could resize it or move it and it would still be able to be moved. So I could move it up here, and as you can see, it's now moved. Or I could click on this and I could resize it, and now it's pushed through. Now I'm going to press the undo button here, and I'm going to move this away, and now I'm actually going to go ahead and customize it so they both have a coincident constraint here. So I'm going to add that coincident constraint, hit OK, and then this one I'll leave that one with a coincident constraint too. Now you can see if I drag and drop this from the catalog, oops, we've still got that extra one over here which I can delete. I'll delete this one too. Now if I drag and drop this out, you can see it's going to snap into that position, but now it won't be movable. So now if I go and resize this, it will actually push the table away, or push the leg upwards, depending on which way you're sizing and so on. But basically now they'll stay connected there so that I can resize the leg easily. Now you might be wondering what the other constraint options do. Now it's a little bit hard to show what they do without something that isn't round here. But basically they lock the direction of the attachment point. So let's put something onto this leg which better explains what I'm referring to. I'm going to drop a block here, just have the block going out in that direction. Very simple example. Now you can see if I drag and drop out this leg, it will position like that, but it can now still be rotated. Whereas if I go in here and I customize this attachment point on this one, a little bit hard to select onto. Let me just move that out of the way. Whoops. Oh, I see that because they're connected. It's going to be a little bit hard to do that. Let me see if I can connect it by select it by zooming in here. As I mentioned, when you've got them in the same spot, it can be a little bit hard to select them there. So what I might do is just delete that concentric constraint that's automatically been added, and now I should be able to move it. Now I'm going to go in and add a new constraint. This constraint will be the coaxis constraint for X, which is going to lock the X-axis, which is that red one there. So it means the X-axis of both items will stay aligned. And we could lock multiple axes if we'd like to, so that they all stay aligned, so it can only stay in that exact position. So each one of these allows you to lock it in position, basically, on various axes. So I'm going to lock it down to all three of these here, and do the same on this. And now you'll see the behavior when we drag and drop that out. Now when I drag and drop it, it won't be able to be moved. We can activate the triball, and you can see if I try to move it, it'll move the whole table, because it knows that's locked and it can't move can't change that relationship between those two items. Okay, so that's a simple attachment point there. Now let's go in and have a look at some of the other options. Let's drag and drop out this leg into empty space, so we can start to customize it by itself again here. Now we have the variables option, which is what I mentioned earlier, which is driving parameter variables. And so if we go and have a look at the cabinet we had earlier, that will explain how they work. Let's drag this out. And currently got this upside down, so let's flip this over and move it out of the way a bit so we can kind of look at it on its own. We could also just hide the other items. So now you can see these ones are pretty standard. They just have a simple constraint for coincident. But in this case we have a male and female, which is a good example of the use case there, because if we didn't, then this could attach the cabinet swung round in the wrong direction, whereas we always want, for example, this piece to be on the same side. So you have a male and female side so that it will always connect in the right way. Now let's have a look at the one with the door. So the way to do this is to set up the one that it lands on, the one for the door lands on, to be the driver. Basically it controls stuff that lands on top of it. So if we go in and set this, you can see it's saying anything with the parameter called door height, that should be changed to equal the cabinet height minus keyboard height. Anything with the parameter called door width, or the variable here. So if I click on it, it's easier to see actually. You can see anything with the variable door width should be changed to equal the variable of cabinet width. And now that's a one-time change unless you tick this as parameter expression. That will add a parameter now that keeps it locked. Now I'll show you the difference between those options here. So I'm going to copy this across, and I'm going to change one but not the other. So this one we'll do set name and behaviors, and this one will turn off the add as parameter expression in each one there. Now you can see if we drag and drop a door on this one, we'll do as we expect and size, and the same thing will happen here. Now if we resize this one, because it's been added as a parameter expression, it will automatically size the door as well, because now they're set to always match. Whereas with this one, you can see it's just set to match it in one go and not set to follow it, because there's no parameter expression being created afterwards there. I'll delete these ones. And let's delete the door and go back in and have a look at this one. So to just mention that one more time, you can see the door height is being driven by those items, and we are adding that as a parameter expression so that it keeps it and then updates. Now, in the item here, we generally want to have our parameters at the same level as the attachment point. So this attachment point is at the assembly level here, the top level cabinet assembly level. Therefore, the parameters it's using or referencing are also at that level. So if we go into the right click and go into the parameter list, and I just only show the ones at the selected level, you can see we've got cabinet height, cabinet width, cabinet depth at that level, that assembly level. The same goes for the door. The parameters we're referencing here are at the assembly level of the door here. We've got door height and door width. And they're currently unknown because there's we don't know what they are yet. It hasn't been dropped onto something. But basically, the parameters you're using in your attachment points, you generally want to have them at the same level as your attachment points. So you don't want to have your parameters sitting at the part level here, at the part level below, and then have your attachment point sitting at the assembly level above. Because you can have attachment points at different levels as well. So you can have it either, you can have an attachment point at the assembly, or the part, or the shape, and so on. Okay, let's delete that now, and I'll just see what other options there are there for me to explain. So to change these, it's pretty simple. You just type in there, and then if you've got one here and you change the value, you just click modify and it'll update the one in here. Or if you want to delete it, you hit delete. Or if you're adding a new one, you just type in a new fresh one, and then you'll be able to click add. Okay, I've also explained the constraints here. The last thing to explain is the catalog item behavior. This is quite an interesting one and also quite powerful. Now, let's go in and have a look at our table again. This is a very simple way of explaining what's happening here. So let's delete this kind of silly one there, silly block that we had on top of that. Now, what I'm going to do is actually create a group of legs here. So maybe I'll create a new catalog. And what I'll do now is also create this same attachment point around our model. So I'm going to create a new one over here. And this one's going to be flipped up like that, 90 degrees. And now we're just going to reorient the tribal 45 with the spacebar, and then I'm going to move it, I'm going to right click and select edit distance from point. We're going to be 100 mil in from that edge and 100 mil in from that edge. Now we've got this called AP from memory. Let's hope that's what I have called it. And then we'll also go in and add that coincident constraint and add these axis constraints. Now, something I haven't mentioned yet is the alias point name Alias, which I'll mention in just a moment. And essentially that is relating to an alias name for the attachment point to make it easier to customize what it attaches to. So let's keep going though here, and I'll show you that in a moment. So I'll quickly add these ones here as well. I'll rotate this one. And again, position it. So I'm going to rotate that 45 and then edit distance from point, and we'll make it 100 mil from that point, and edit distance from point 100 mil from that point. And then we'll click on set name and behaviors, and now we'll go ahead and do AP, and we'll do neutral and add the constraints that we want to add there. Now we'll do the same over here, and I'll add another attachment point. And this is the last one, and then I'll show you the other behavior there I was referring to. So let's move this one in 100 mil and 100 mil from there. Now we have those points, and I do need to rename this one to be also called AP and neutral. and have the constraints that I'd like. So now we have those done, and now if we have this leg in our catalog, we can simply drag and drop it out, and it will attach to the various points, whichever one it's closest to when we drop it. Just like that. I'm going to undo that for now. And I might just rename it to leg. Make it a little bit simpler. And we'll name this table. Now, let's go in and create a few different types of legs. So I'm going to create a few copies here. The tri-ball. Create a copy. I'm going to create maybe 4 copies. Now this second one here, I'm going to make a little bit longer. And I'm going to call this one leg long. Well, maybe I'll just call it long, one word. Just like that. And then this one will be called, I'm going to change the color of it. So I'm going to call this one blue. So I'll make it blue. This one's going to be called blue. And this one will be called green. Just like that. We don't need the last one in this case. So now we have those different items. Now if we wanted to, we could drag them all into the catalog like this. And we don't need our original one just called part 28. We've got better naming now. And now we'll just drag and drop out the first one. As you can see, that will attach like so. Drag and drop the green one here, or drag and drop out the long one. And as you would expect, they're attaching to the various points we drop them onto. But what you can do with the option I was mentioning earlier is you can actually customize what one gets dropped out if these are in a group. So you can see if we go in here and select down to our attachment point, and I can select onto it. Oh, we've got a constraint there. We just want to delete actually. There we go. So set name and behaviors. The catalog item will refer to the item that is used when dropped onto this this position if it's in a group. So I'm going to tell this one to use green, and I'm going to tell this one to use blue. Now they won't use those items now if we just drag and drop items, because we're still saying, actually no, we don't want to use that, we just want to use the standard one here because we're actually choosing it. But if we have this a little bit different, so for example we have a group, so let's create a group here. Well, we can just create group from those items. So now we've got a group with the blue and the green. Now we can actually drag and drop out the group. So these parts don't have to be the same. You know, in our case, we've just got different colored parts. But these parts could be completely different. So instead of driving them with parameters and dimensions, you can actually drive them with the catalog just with different parts in a group. You can see if I just drop this group onto here, it's going to use the green. If I drop onto here, it's going to use the blue. Because this attachment point is now asking for a specific type. So this doesn't have to just be blue and green. This could be metal leg and timber leg. This could be a certain variation of a much more complex model. This could be a type of wheel added to a vehicle, for example. Basically the attachment point on the table is requesting a variable or type of the item being dropped. So this group then becomes legs, and the actual item is requesting the type of leg which gets dropped out onto it. When it's dropped from a group. Again, if you want to drop individually, you can still change that behavior just by dropping individually. Like if we drop a green here, it will still be a green because we're actually dropping from inside the group like that. But that's a very nice way to automate the behavior of different items attaching. For example, if you have different feet going onto an item, based on if the item is round or square, you can have square feet or round feet, just based on those catalog references there, which basically tell the item what it wants from that catalog group, what item it wants from that group. Okay, the last thing to mention here is the, if I can find it, is the attachment point name alias. So The alias essentially refers to what the attachment point is called. Now this makes sense when we have something complex. This is quite simple, but we should still be able to demonstrate it with this model. So let's say I drag and drop out the green leg here, but this time I, oops, didn't mean to replace my model. This time I right click drag. Now you can see I'll get all these options. I can connect to all the different points. I can now select the different points I can connect it to. So this is useful because if we have something really complex, we may want to control where the item goes to instead of having to try to find it when we first drop it. You know, for example, if we have something really complex, you might not be able to get the mouse close to the item we want to drop onto. Maybe we want to connect to there, but that's blocked off by some big thing in the way on this side. So we want to drop to here, but we don't want it to go there. So what we do is we drop to there with a right click, and it gives us that selection option here. So the reason the alias is important is that, as you can see, these names look incredibly confusing, and we don't really want to have to read these names, do we? So we don't want to have to, you know, you can click and see here, obviously, and we've only got a few of them, so it's quite easy to see which one's which. But in a more complex example, you may want to just have names that better explain what's being referred to. So because of that, we can then set names. So I'm going to go ahead and set a name on our green one here, and I'm going to call this one have an alias of green. You can also link the alias to other attachment points that are the same of linked attachment points, or you can uncheck for your unique alias between the attachment points still. So for example, the attachment point may be linked, may have the exact same type of attachment point linked around your model, but you still may want to have different names for where that attachment point is positioned. So you can check that or uncheck that. I'm going to leave it unchecked. Call that one green, like that. So now it's really simple, it's just showing the alias. And now here, I'm going to go ahead and let's just have a look, if we look top down, what this is. So I guess it just doesn't really matter, it's the direction we aim the camera here. So I'm going to pretend our camera is aimed in this direction. So this is going to be top left, top right, bottom left, bottom right. Okay, so we'll go on to this one. And I'm going to set this one as top left. I'm going to set this one as top right. And I'm going to set this one as bottom left. I'm going to set this one as bottom right. Now you can see if we go through that same dialog we were in before, I'll just drag a new green one in here, which has the new naming. When I drag and drop that with right click, you can see the naming here is now a lot easier to understand. It's just, we want the top left and green to connect. We want the top right and green to connect. We want the bottom right and green to connect. We want the bottom left and green to connect. So it's now really easy to understand, as opposed to having the default attachment point name, which can sometimes be a lot more complex. So that's how the alias option works with attachment points. Hope I've covered everything there in the attachment point settings. There of course are a lot of different settings you can customize. But I think that's just about it. Hope that's helped.